Hello, everyone. Our group presentation is about the effect of artificial intelligence and machine learning on engineering design and really our everyday world. My name is Keyshawn Soni, and I am a junior studying biomedical engineering.
My name is McKenna Wiseman. I'm also a junior, but I'm studying chemical engineering.
My name is Adel Sadiq. I'm also a junior, also studying biomedical engineering.
And my name is Daniel Hoy. I'm a junior and I'm also studying biomedical engineering.
In our topic description, we're studying how artificial intelligence and machine learning are reshaping the way we approach the field of engineering. We're studying how this affects engineering design, how this affects manufacturing and simulation processes, and what are the key educational outcomes that engineers need to remain competitive and remain fluent in this field.
I want to begin with a broad overview of how AI is currently being used in engineering. Across industries, artificial intelligence tools are becoming an integral part of everyday engineering work, not just in labs or experimental settings, but in real production environments. We're seeing AI play a role in areas like design optimization, digital simulations, predictive maintenance, and strategic decision making. For example, in design, AI algorithms can rapidly generate and evaluate thousands of possible design configurations, far faster than traditional methods. In simulation, AI speeds up processes by approximating real-world conditions using machine learning, which can significantly reduce time and computational costs. When it comes to maintenance, AI can predict failures before they happen, helping engineers and companies avoid downtime. And in decision making, AI can help process vast amounts of data to inform complex engineering choices. So, therefore, overall, AI is helping engineers work more efficiently, solve complex problems faster, and increase productivity at scale. Now, looking at how engineers themselves view AI, according to a recent study published in Science Direct, engineers believe that around 34% of their current tasks could potentially be handled by AI. That's about a third of their workload, which is pretty significant, but it's important to understand what kind of task AI is expected to handle. Engineers primarily see AI as a way to take over repetitive, routine tasks, freeing up their time for more strategic, creative, and high level thinking. AI is also seen as a tool to improve accuracy, especially in areas involving large data sets, simulations, and testing environments. For instance, AI can catch errors in design early or identify trends in performance data that a human might miss. So rather than replacing engineers, the precipitation is that AI will become a collaborative tool, one that makes engineers more effective at their jobs by removing some of the tedious workload. Shifting into the educational side of things, AI isn't just changing how engineers work, it's also changing how they learn and prepare for the profession. A recent survey shows that 75.3% of engineering students already use AI-based tools in their studies. These include tools like coding assistants, AI-powered calculators, machine learning models for simulations, and AI chatbots for studying complex topics. AI is becoming used not only for completing assignments, but also for problem solving, decision making, and even conducting advanced research. A study published in Nature highlights how AI enhances the learning experience by making education more personalized and efficient. Students are using AI to receive instant feedback, simulate real-world systems, and better understand concepts through interactive tools. The big takeaway here is that students are becoming more comfortable and fluent with AI early on, which means the next generation of engineers will enter the workforce with a very different skill set than previous ones. AI adoption isn't limited to a few industries or companies, is becoming universal trend across the entire engineering landscape. We're seeing rapid growth in AI use within mechanical engineering, civil engineering, aerospace, electrical, and even niche fields like material science and environmental engineering. Companies are investing in AI because it offers a competitive advantage whether that's through reducing time to market, lowering developmental costs, or improving product performance through smarter design choices. As AI tools become more advanced, they're being used to tackle increasingly complex tasks such as running real-time simulations, optimizing supply chains, and predicting system failures. Looking ahead, industry experts predict that AI will become deeply embedded in engineering processes, not as an add-on, but as a standard component of design and analysis. So the trend is clear. AI is no longer something that's coming soon. It's already here and it's growing fast. So, to summarize, it's clear that artificial intelligence is already having a major impact on engineering, and this impact is only going to grow. AI is helping engineers automate time-consuming tasks, improve the accuracy of their simulations and designs, and solve problems that were once considered too complex or costly to tackle. We're seeing adoption not just in industry, but also in engineering education, where students are being exposed to AI tools early and often. This is leading to a new generation of engineers who are not only skilled in traditional methods, but also in data-driven and AI-enhanced approaches. The future of engineering will likely involve even tighter integration with AI systems, whether that's through generative design, smart manufacturing, or digital twins. Ultimately, AI isn't replacing engineers, it's evolving the profession, and those who learn to work with these tools effectively will be the ones leading the next wave of innovation.
All right, moving on to changes to the traditional engineering design. Artificial intelligence and machine learning aren't just changing the tools that engineers use, they're fundamentally transforming how engineering design and simulation are approached. Traditionally, the design portion has been a manual step-by-step process, relying heavily on human intuition and repetition modeling. But today, AI and ML are automating many of those tedious tasks, allowing engineers to explore hundreds of design possibilities in a fraction of the time. This shift is leading to faster, more informed decisions, especially in the early stages of the design process where flexibility and creativity are crucial. According to a focused literature review published in AI EDAM, around 35% of AI-related engineering studies now apply AI methods across multiple design stages, with the greatest impact found in the conceptual and preliminary phases. In these early stages, AI-driven tools help engineers rapidly generate and test design options under various constraints, optimizing for performance, cost, sustainability, and even manufacturability. From neural networks that predict structural performance to natural language processing that translate user needs into technical requirements, AI is helping turn raw data into actionable design solutions. This integration marks a major departure from traditional design methods, ushering in an era where engineers no longer rely solely on static models or guesswork. They co-create with intelligent systems. One clear example of this evolution can be found in structural engineering. As highlighted in a 2020 article by Tai in Structures, machine learning has significantly improved structural design by reducing computational effort, increasing precision accuracy, and accelerating iteration cycles. ML models are also being used to proactively monitor potential failure points, enhancing safety and reliability. These innovations mean engineers can now rely on data-driven simulations and predictions rather than waiting for physical prototypes or real-world performance data to guide their decisions. But the transformation doesn't stop at technical tools. The rise of AI in engineering also changes how teams work together. As discussed in Current Opinions in Psychology, AI teaming, where humans collaborate with these intelligent systems, requires engineers to adopt new communication strategies, workflows, and ethical considerations. These human AI teams are interdisciplinary by nature, involving not just engineers, but also experts in psychology, data science, and organizational behavior. As AI becomes a more active participant in engineering tasks, engineers must learn to evaluate its outputs critically, understand its limitations, and integrate its suggestions within the broader design context. To stay competitive in this changing landscape, future engineers will need more than just technical expertise. They need to develop data literacy, including the ability to interpret AI-generated insights and apply machine learning principles to real-world problems. They'll also need strong collaborative and adaptive skills, especially when working in diverse cross-functional teams. Communication, critical thinking, and ethical reasoning will become just as important as coding or CAD modeling. In conclusion, AI and ML are not simply tools, they're reshaping the foundation of engineering design and simulation. They enable faster, smarter, and more collaborative workflows that push the boundaries of what engineers can achieve. For those entering the field, success will depend not only on mastering new technologies, but also on learning how to work with them and with each other in entirely new ways.
So, when talking about artificial intelligence, it's come a long way since its early beginnings. If we look at the evolution of AI, we can divide it into three main categories. The AI originally, the narrow AI, general AI, and then super intelligent AI. Now, if you take a look at narrow AI, that's what most of us interact with today. It's things like facial recognition, language translation, and spam filters. These are systems designed to perform specific tasks, better than humans theoretically, but they can't operate outside their domain. And then you have general AI, which is still largely theoretical. General AI is able to perform really any task, intellectually speaking, a human can do. It has the ability to reason, plan, learn, and adapt across a range of situations. We're not there yet, but it's the long-term vision that many scientists are working towards. And then you have super intelligent AI. That's the AI that surpasses human intelligence in virtually all areas. Super intelligent AI is more of a ethical debate at this stage in the game, but it raises important questions about safety and how we can align with our values. And we have to find ways to create these ethical AI models in the future. So, what does this mean for the foreign policy landscape? Well, AI is increasingly becoming sort of a strategic asset at the global stage. It's reshaping how countries interact, compete, and cooperate. So one major area is national security. AI is now embedded in military decision-making, surveillance systems, and autonomous weapons. Governments are investing heavily in AI to gain technological superiority, which introduces both opportunities and risks. And speaking of those opportunities, another aspect is geopolitical competition. You know, the two biggest nations that are in a race for AI dominance are the US and China, and not just for economic power, but for setting the global norm. So this tech rivalry is influencing our trade, it's influencing our partnerships, it's influencing our defense strategies. And then we take a look at diplomacy and soft power. AI can enhance diplomatic efforts through data analysis and prediction tools, but it can also be used for disinformation, as we've seen in some election interference cases. So what we have to do is figure out how we can use AI for information and authentic information, not misinformation and disinformation. How do we stem disinformation is the big question. Lastly, you take a look at the global governance of AI, which is becoming increasingly critical. There's a growing need for international cooperation to create ethical frameworks, regulate, AI applications, and ensure that these technologies are being used responsibly. And of course, this is a cross-border situation. This is a collaboration between different countries and different sectors, like the policy, tech, and legal sectors. So AI isn't just a tech issue anymore. It's a core part of foreign policy planning and international relations. Nations that understand and effectively integrate artificial intelligence into their strategies will shape the global order.
Okay, so some general recommendations we have for people who are interested in AI engineering. Number one, embrace interdisciplinary skills. as future engineers should develop not only technical expertise, but also working knowledge of AI and data science. Understanding how to collaborate with AI systems will be essential in the future. Number two, integrate AI and engineering curriculums into our courses today. Universities and training programs should expand AI-focused modules covering topics like machine learning, data analysis, and ethical AI usage. Number three, upskill in AI tools and software. Professionals should continuously learn tools such as Python, MATLAB, TensorFlow, and CAD software with AI plugins to stay competitive. Number four, promote AI and human collaboration. Rather than viewing AI as a replacement for human workers, engineers should treat it as a collaborator that enhances decision making, speeds up workflow, and reduces error. Number five, prioritize ethical AI implementation. Engineers should ensure that AI solutions are transparent, fair, and secure, especially in high stakes applications such as structural safety and medical devices. Some recommendations we have for education systems to stay current in AI research in engineering journals. To keep up with how AI is impacting engineering, it's a good idea to follow journals such as the IEE or Advanced Engineering Informatics. Even just reading abstracts can give you insight into latest tools, trends, and real-world applications of AI. Another recommendation is to enroll in AI or machine learning courses. So formal courses in AI or machine learning, either through schools or platforms such as Coursera, can help you build solid foundation. You can also learn how algorithms work and how to use tools such as Python or TensorFlow in these engineering tasks. Take electives or online courses focusing on this topic. If your program doesn't offer AI-specific electives, online courses are a great alternative. Many of them focus on how AI is applied directly in design, manufacturing, and system modeling. Number four, get hands-on experience with projects. Applying AI in real or class projects help turn theory into skill. Whether it's using data to detect part failures or optimizing design with AI. Hands-on work shows that you can use these tools in practice. Apply AI tools in projects, for example, using machine learning to predict material fatigue. One great use in this case, using machine learning to predict material fatigue. By analyzing stress data, AI can predict failure points more accurately than traditional methods, which improves safety and saves time. Finally, learn AI-enhanced software. Tools like Siemens NX and Fusion 360 now have built-in AI for simulation and generative design. Learning how to use these gives you a real advantage as more companies move toward AI-powered workflows. Some recommendations for those pursuing a career in AI engineering is explore or being open to emerging roles such as AI simulation. New roles such as AI simulation or data-driven design engineering are becoming more common. These jobs combine traditional engineering with AI tools, so it's worth looking into what skills they require. Understanding how AI affects engineering roles across industries. AI isn't just showing up in one field, whether it's automotive, aerospace, or manufacturing. AI is changing how engineers design, test, and optimize systems. Understanding this shift helps you stay adaptable. And learn how to communicate AI concepts to non-technical audiences. Engineers who can explain AI ideas to non-technical teams, like managers or clients, stand out. It's not just about building models, it's about making the results understandable and useful for decision making. Another thing you can do is revise your resume to highlight both technical and AI related experiences. It's a good idea to revise your resume to show that you have experience in AI. Uh, this includes things such as projects, tools you've used, or courses you've taken, even small things so that you're AI aware. And finally, show practical cross-functional skills, as employers want engineers who can apply AI across areas like design, testing, or quality assurance. Those who can clearly explain what this data means. The combination of technical skill and clear communication is in high demand.
In conclusion, AI and machine learning are revolutionizing the engineering world. They enable faster, more accurate, and data-driven design decisions. They're most effective in early stage design, but their impact is growing across all phases. Adoption is expanding in both industry and education, showing a strong shift in how future engineers will work. AI is helping engineers automate routine tasks, explore more design possibilities, and ultimately deliver safe and more innovative solutions. Finally, here's our references. Thank you for watching.